Okay, so in this video, I'm going to quickly take you through how to do arc length and sector area with circles, whether you're using degree angles or radian angles. So first, we need to make sure that we know how to find either the circumference or the area of a circle. So when we say exact circumference, we mean pi is going to stay a symbol. You're not going to type it in as like 3.14 in your calculator. So we want to remember that our circumference formula is 2 pi r. They tell me my radius is 10 inches here, so my circumference for this circle is going to be 2 pi times 10. You can also put it in parentheses, and 2 times 10 is 20, so that's going to be 20 pi inches. My area formula for a circle is going to be area is pi r squared. So again, exact area, we're going to leave pi as a symbol, and our radius here is 10 inches again. So my area here is going to be pi times 10 squared. So 10 squared is 100. I'm going to put my pi on there, and then my unit would be inches squared. So if you can do those two formulas, and if you're a little comfortable with fractions, you can finish this by this whole thing, right? Arc length and sector area are just fractions of those formulas. So arc length is how long it is between 2 points on a circle. I like to think of it as how long your crust is on your slice of pizza. So arc length is just going to be a fraction of the circumference. And I don't know why, but the notation for this is often the letter S. I don't know why S stands for length of an arc. It probably goes back to Greek or Latin origins, but we use the letter S oftentimes. So the formula is very similar whether you are in degrees or radians. So we'll start with degrees. So if you're doing arc length, and remember with the video, you can pause, rewind, fast forward, change your playback speed, right? This is your notes, you do what you need to do. If I'm talking too fast, slow me down. Okay, arc length formula is going to be S, and then it's a fraction. So we know in a circle that there is 360 degrees, and we're going to do, in the top of that fraction, we're going to put the symbol theta. So this symbol theta, and that is pronounced T-H-E-T-A, theta, that's a Greek letter, and that's the Greek letter that we often use to stand for angles. So you're going to see that a lot in the rest of pre-calc. So we're going to do the fraction of the whole circle by taking our central angle theta, dividing it by the 360 in the full circle, and then multiplying that by the whole circumference of the circle. And I'm going to put that over 1, so it's a fraction times a fraction, so we can see to go straight across. So for our first example, we want to find the length of arc EG. So we need to know, well, how long that guy is. If the angle inside EFG is 60 degrees, and it says that EF is 3, so that's our radius. So our theta value here is 60 degrees, and our radius is 3. So to do our arc length formula, I like to write it out each time. Arc length is going to be theta over 360 times 2 pi r over 1. So our arc length here is going to be 60 over 360 times 2 pi times 3. Now I'm hoping 60 over 360 you can do in your head. That's going to reduce down to 1 over 6, right? And then 2 pi times 3 is going to give me 6 pi over 1. Well, a 6 and a 6 are going to cancel out like that, right? 1/6 of 6 is just 1. So my arc length here for this problem is just going to be pi. So let's try that formula again, but using some different numbers. In example 2, we're going to find the arc, I don't know why I can't speak today, the length of arc EG, but this time EF, so the radius is 10, right? And then our angle is going to be 45 degrees. So again, our arc length formula is our angle over 360, right, times 2 pi r over 1, right? Every time you write it, it just gets a little bit more ingrained in your brain. So I'm going to have 45 over 360 times 2 pi and times 10 up here. Okay, so let me see if I can get my calculator out here. calculator. Okay, so we had 45 divided by 360. So on your calculator, if you type that in, you get 0.125. And the easiest way to turn that into a fraction, as a reminder, is to hit the math key and then just hit enter 2 times for that math frac button. So our fraction there is 1/8. Where am I? I think I'm here. Okay, so if we reduce our fraction, we get 1/8, and then 2 times 10 is 20, so we get 20 pi over 1. Okay, so if I go straight across here, right, that's 20 pi over 8. And then we always want to reduce our fractions, which you could use the calculator to do. You just don't type the pi in. Or we could know that they're both divisible by 4, so we get 5 pi over 2. Right. So it's a matter of just plugging into the formula most of the time and then simplifying your fractions and multiplying. But we can also use this formula to work backwards, right? If we have the answer to what the question's supposed to be, we can work backwards to find either the missing angle or the missing radius. So in example 3, we have that the measure of angle EFG is 135. Okay, so we know theta is 135 degrees, and we know that the length of the arc, so S, is 10. In this case, we want to know what the radius is, so that's like our missing variable. So if we write down our formula, S is equal to theta over 360 times 2 pi r over 1. And we're just going to plug in for everything we know and then use our algebra skills. So S is 10, so I'll replace that with a 10. Theta is 135 over 360 times 2 pi, and I don't know r. Okay, so what I'm going to do first is I'm going to take all of this and combine that. I'm going to do the multiplication. So let's see, can I figure out how to split screen this? That would be lovely. I don't want to do that. They changed all of the iOS on me, so now I don't know what to do. Okay, but anyways, I'm going to make a fraction. So I have 135 over 360. And then I'm just going to multiply that by 2. I'm going to leave the pi off my calculator so I get a fraction back. Now, if your calculator doesn't give you the fraction, we know what 0.75 is as a fraction. Otherwise, remember, math, enter, enter. So we get 3 over 4. So if I simplify that on my calculator, I get 3 over 4, and I'm just going to put the pi up there with the 3. So the pi is going to stay in the top because that's where it was in the problem. So that's 10 equals, and then bring down my variable of r. Now, if I want to cancel out a fraction to both sides, the easiest way to do that is to multiply both sides by the reciprocal of that fraction. So just flip it upside down and multiply on both sides, right? Because my 4's cancel and then my 3 pi's cancel. And then here it's like 10 over 1, so I'm just going to go straight across. So my answer here is going to be 40 over 3 pi. Right, so you write down what you know, you write down your formula, you plug in, and then you use your algebra skills to work backwards. So that's arc length in degrees, and it's very similar when you're in radians. And I think it's actually easier when you're in radians. So we know that for radians, 360 degrees turns into 2 pi radians. So we change that part of the formula to be radians. And then let's leave everything else the same. Right, so if I plug in my circumference formula as well, I can see that I have a 2 pi in the bottom and the 2 pi in the top. Those cancel out, and my arc length formula in radians is actually just my angle times the radius. It's super simple. So if we go to page 2 of these notes to do our arc length, right, they say we want to find the length of arc EG, so find S. If EF is 10, okay, so here's our radius. And our theta value is pi over 6. And I don't see a degree symbol, so we know we're in radians, right? So we want to remember in radians. I'll write it down again, right? Arc length S is just our angle in radians times our radius. So here, that's going to be pi over 6 for our angle times a radius of 10. And if it makes it easier, you can make that 10 over 1. You're going to go straight across your fraction, so 10 pi over 6. And then we can reduce both the top and the bottom by 2 to get a final answer of 5 pi over 3. And just like with degrees, you can work backwards with this formula as well. So And number 5, right, we want to find the measure of angle EFG. So we got to find theta. We don't know what that is. We know the length of arc EG is 5. Okay, so S is equal to 5, and they tell us that the radius is 2. So remember, our arc length formula is our angle in radians times our radius. So if the arc length is 5, I don't know theta, that's my unknown, so I'll leave it as a variable, and my radius is 2. Well, this is now just a one-step algebra 1 problem, right? Divide both sides by 2. So 5 over 2, or 2.5 radians, is going to be equal to theta. So that's arc length. And sector area is very, very similar. The only thing that changes for sector area is that it's a fraction of the area and not a fraction of their circumference. And we know that the area formula for a circle is pi r squared. So that's the only thing that's going to change. So sector area is like finding how much pizza is in your slice of pizza, whereas arc length is how long is the crust along the edge of your slice of pizza. So for sector area, I like to use the abbreviation SA for sector area. So we're still going to set up the same fraction. So we've got theta over 360 for degrees, right, times pi r squared for the area formula of a circle. So in number 6, right, we have sector area. We know that the radius KJ is equal to 3. So here is our radius, right? And they tell us that the measure of angle KJL is 60 degrees. So there is our theta. So our surface area here is going to be 60 over 360 degrees, right, times pi r squared. R here is 3. Now, you could do this longhand, of course. I'm going to just show you how to do it all in the calculator in one step, because I think sometimes we struggle with that. So if I go to my calculator, I'm going to set up the fraction. So 60 over 360 times, I'm not going to put the pi in. I'm just going to type in 3 squared. I get 1.5, which if I don't know what that is as a fraction, I hit math, enter, enter, and it gives me back 3 over 2. So then all I'm going to do is say that this is 3 over 2, and I'm going to put my pi in the top of the answer. Now, you could also do this longhand, right? You could say this is 1/6 times 9 pi over 1. 9 over 6, you can reduce both of them by 3, and you get the same thing. Right? If you are feeling kind of okay and you want to try some on your own, I encourage you to pause the note video now, try example 7, and then you can tune back in and watch me do it to check your answer. Okay, so when I'm reading through number 7, the sector area is what I want to find. Okay, so sector area, I need to know my formula. I'm going to write it down. So theta over 360 times pi r squared over 1. Okay, KJ, and that's right here, right? That's 10, so that's my radius. And then the measure of the angle is 45 degrees. That's my theta value. Okay, so now I have enough to plug in. So I've got 45 over 360 times pi times 10 squared. Right, and I'm feeling really lazy. I'm going to use my calculator. I'm going to do, okay, alpha fraction, 45 over 360 times, you could put in another fraction if you wanted, 10 squared over 1. You're not going to put the pi in. My calculator likes to give me math decimals, so math, enter, enter. I get 25 over 2. So that means my answer is 25 pi over 2. Right, just using my calculator there. Okay. So we're going to come back to the sector area in radians in a second, but before that, we're going to turn our page and we're going to do a working backwards question. So we're given in number 8 that the area of the sector, okay, so our sector area is 10 pi. And we know that theta is equal to 50 degrees, and we want to find the length of KL. Okay, you know what? In class, I did this differently. We're going to do KJ. There we go. Just change that to KJ. So we want to find the radius. Okay, so I'm going to write down my formula. So my sector area is equal to theta over 360 times pi r squared over 1. Okay, so my answer, my sector area is 10 pi, and that's supposed to be 50 over 360 times pi r squared, and I don't know r. So the first thing I notice is that each side of the problem has a pi, so I'm going to cancel out the pi's. And then I'm also going to reduce my 50 over 360, right? I'm just going to cross off the zeros because they can both be reduced by 10. Okay, so I have 10 is equal to 5 over 36 r squared, right? I'm going to multiply both sides by the reciprocal of that fraction to cancel it out. Okay, so 36 times 10 is 360, and then divided by 5, right? So 36 divided by 5 all times 10 is going to give me 72. Okay, so we're just going to go up here. We've got 72 is equal to r squared. We know to get rid of a square power, you take the square root of both sides. Now, I could type in the square root of 72 on my calculator, but let's be a little bit more exact than that. Hopefully we remember our perfect squares. So 72 is 36 times 2. So I can rewrite the square root of 72 as the square root of 36 times the square root of 2. And we know that the square root of 36 is 6. So my final answer here is 6 root 2. You've been hanging in there. I appreciate that. The last thing we need to talk about is sector area in radians. So that's what number 9 is about. So I'm going to scroll back to fill in our formula. So just like with arc length, right, the only thing that really initially changes is 360 degrees becomes 2 pi. And then everything else stays the same. Now, just like with arc length, we have a 2 pi in the denominator, and we have a pi in the numerator, so those are going to cancel out. And then I have an invisible 1 next to the theta, so what you'll often see this written as is a 1/2 times theta times r squared. You can also do theta r squared all over 2. You can leave it as a big fraction. So we're going to use that formula down here, so I'll write that again. We're going to find the sector area of the shaded region, given that kj, so the radius is 13, and pi over 6 is my theta value. Okay, so surface area is going to be 1/2 times my angle of pi over 6 times my radius squared, so 13 squared. I'm making a fraction, so it's just tops times tops, bottoms times bottoms. Okay, so if I go straight across, I know 13 squared is 169. If you don't know that off the top of your head, right, you can use a calculator. I'm going to put my pi in the top. And then in the denominator, I have 2 times 6 times 1, so that's going to give me 12, and that fraction does not reduce. So that's all there is to it. So again, if you're feeling like you want to try some on your own, go ahead and pause, do number 10 on your own, and then check back in, and this is the last problem we're going to go over today. So in number 10, they're telling me that my radius kj is equal to 10, and they're telling me that my theta value is pi over 4. Okay, so I'm going to write my formula, and then I'm going to plug into my formula. And I'm writing the wrong formula there. Okay, so 1/2 times theta times r squared. Okay, so my surface area is 1/2 times pi over 4 times 10 squared over 1. Okay, I'm going to do this longhand. So 10 squared is 100, and then I have a pi in the top. 2 times 4 times 1 is 8. And I know that both of those numbers are divisible by 4. So I'm going to go ahead and reduce by hand. So I get 25 pi over 2, which is also what you should get if you're using a calculator.